So ghvmath.com or mrword.org or hsmath.org. I think that's the other address, but probably ghvmath is the one. Takes you to here. You can scroll down the page, see what we did yesterday. That's kind of always thing I try to update it every day, or at least every night. If you click the daily lessons, you can go down to the drop downs. You guys are obviously geometry. That's if you want to see like all the stuff we did, not just what we did yesterday. So I'd go down to geometry under daily lessons, and here's your online textbook. So that's where you can access the link to. You can even bookmark that web address. So again, I think I sent out a link to my website through that Google Classroom last night, so you can find it. So you can go in there and you can log in and see what your login is. Now, I think I told you what your login is, so I'm going to write it on the board, but I'm not going to say it out loud. That way, no weirdos on the internet kind of figuring out. So for Fuentes here, this is how you're going to log in. Okay, full, right, first, last with the dot, and then this is your password. And this has to be capitalized. So that's how you log in, and that textbook will show up. Okay, so try it out today when we get a chance, and I'll make sure that you can get logged in and stuff. Okay, that way, if you don't want to carry that 10-pound book, you can just use that. So, all right. Okay. All right. Questions at all about online textbooks or anything like that? Okay. Again, we're out of here at 9. Now let's go through a couple notes here today. So. Okay, first of all, we got to talk about 3 vocab words today, and then we got to go through a couple examples what your homework is going to exactly look like. So, vocab terms, that's a big part of the test. So when I assign a test, coming up here, probably in about a 2-week period, 2.5 weeks, something like that, there is vocab. I think there's like 8 vocab words on this test. I just pick randomly throughout the chapter. So when we get to like review days, I'll show you what I'm talking about. I'll walk you through the textbook so you know how to look through that textbook and you know exactly what words I could potentially pick from. Because again, I just picked from the textbook, this chapter 1, right? Notation, this is gonna be a big thing for the homework today. It's how you write your answers. I'm super particular on how you write your answers. You have to be very detail oriented in here. So we'll talk about that, and then we'll try to get to homework today, which I have written on the board over there. It's always on that second line. I think it's that purple marker over here. So I've already written down the homework, which is potentially due for Friday, but if we need to change it, I'll change it. So you guys are always that second line. So that page 8. So that's also be on JMC. It'll be on my website, and I'll probably send out a link via Google Classroom just to remind you guys. So that way you got 3 places where you can look to know what the homework is and what the due date is and all that. Right now it's tentatively due for Friday because a lot of it's just vocab. Look at a picture, tell me some things about it. Very open-ended, as we talked about yesterday. But let's go through some vocab words. That way you know exactly what you're looking at and you know exactly what the book's even asking you to do. So first of all, let's talk about the first word, point. I know it seems weird, just point, right? So here's the drawing of it, right? You have a dot. You have a capital letter next to it. When you look at a book for the geometry textbook, there'll be diagrams, there'll be a ton of dots on the picture, they'll all be labeled with capital letters. So the definition of it is it is a point in space labeled with a capital letter. It's a location. That's like the key word there. It's a location. We talked about that yesterday when we did that little example where I had you guys do that little challenge question yesterday. You had to find the specific location that met that, those 2 descriptions I gave you. That is a very specific point. It is non-measurable. What I mean by non-measurable. You cannot put a ruler and check the thickness of it. It's infinitely small. But it just represents that one pinpoint location. Like on an iPhone or an Android phone, you have pixels on the screen. The pixel will represent a point, a very specific dot. But it's labeled with a capital letter. Now, how you write it. So let's say you're looking at a very, very distinct diagram, something like this. Here's a little box, some geometry shape. It is a rectangular prism. We'll eventually learn that in the other chapters. Maybe we're looking for a very specific point. This spot right here, right? That corner. So maybe it just has to name one of the edges or one of the corners. So when you name it, you're going to write point, the word point, and then you're going to put the capital letter after it. This is what I want to see if they ask you to name a location. You have to write the word point and then the capital letter. If you forget the word point, I count it wrong. That's how specific it needs to be. So when you label a very specific location, write the word point, capital letter after it. Got it? That's if they're asking for like intersections and stuff, and that's another vocab word we'll go through a little bit later. So that's a point, location and space, very specific. Now, I've even said the word space. Not the final frontier, not outer space. Space is just the set of all points. So what I mean by that, by the set of all points, I'm talking that when you have a picture and the picture has like 50 different points, dots all over it, right? Go back to my diagram over here. Maybe there's just a bunch of dots on this picture. That is the set of all points. It's all of them. You just have to pick one specific one if I want to point. So space is like three-dimensional, right? But a point is two-dimensional. It's just two items came together to make that point. That was the trickery of yesterday when you guys were doing that little challenge question. I led you a certain direction when I asked you to find a certain location. You guys were thinking about these magnets, and you were so focused on just putting a magnet on the board. When I was looking for three-dimensional space, you'd be floating out here in the middle of nowhere, right? This is something that eventually you'll get used to, especially like three-dimensional items in your textbook. They're super difficult for people to see. I had a couple people from previous years. They honestly cannot see items in 3 dimensions when it's printed in a textbook. They can't get this idea like this is a shoe box. Like you have that physical box in your hand, you can rotate it, look around it. They can't see it. They couldn't see, is this dot in the back? Is this one in the front? They just couldn't spatially figure out what they're looking at. Some people just think that's weird. To me, when I see that, I can kind of figure out how to manipulate it, move it around. But again, I play a lot of video games, so that doesn't affect me at all. I'm just used to that three-dimensional space kind of a thing. But for some people, when you look at your textbook today, we're going to look at a couple examples of that. This can be super disorienting, you don't know what you're looking at. We're going to look at a couple examples today. I'm going to have you open up your textbook. We're going to look at a couple things. Questions with the word point or space, though? Okay, take silences. You're good, or maybe you're just too scared to say anything. All right, let's talk about the next item. Oh, this eraser's terrible. All right, let's talk about the next word. I need to towel. This can't work. All right, so the next item. We need to talk about when you actually have points, like multiple points on a picture. Now they're forming an actual item, a geometrical shape. So one of the shapes we need to talk about is a line. You guys know what lines are. You probably draw them all the time in elementary days, but there is a very specific definition in geometry. In fact, this is a thing that we're going to get in the second section. There is 3 types of lines. 3 types of geometric lines, like the shape itself. The first one we're going to talk about is self-entitled. It's just called a line. This is the first one we're going to learn. It's just called a line. Let's go through the definition of it. It is formed by 2 points and extends in both directions without limit. So it's a geometrical figure, right? It's an item that contains 2 points, it's formed by 2 points, and it extends where, it's an item that passes through both of them and extends in both directions without limit. What does it mean to be extending without limit? What does that mean? Please.
It goes on forever.
Yeah, it goes on forever, right? There's an infinite number of dots that are on there, but you have 2 very specific points. You can call them any letters you want. Let's call them X and Y. And you have all the dots that connect it and keeps going. So they have arrows on it. They have arrows on both ends. That's a line. There's an infinite number of dots on that line. You can pick any dot in between. There's this weird axiom. It's based on an old Greek myth with Achilles and what is the other person name? Hector, where they're chasing each other around the city of Troy. The idea is that there's always a halfway point, right? There's always a halfway middle between the two. So if Achilles was, chasing Hector, and he always made up the distance by half, he was always gaining half the distance when he was chasing, would he actually ever reach him? The answer is no. There's always another halfway point. There's an infinite number of dots on that line. That's what you got to think about. Now, when we name a line, when you do the notational thing, when you have to write an answer, maybe you're looking for a very specific line that goes through 2 points. When you name it, you have to write both letters down, capital letters preferably. It doesn't matter the order you write them. You can write YX or XY, and then you got to draw a picture above it with the 2 arrows. That's notation. Or if you don't like that, if they give it an italicized letter, sometimes they'll draw a line, they'll have a bunch of dots on it, M, S, T, whatever. There's a bunch of dots all over that line, but suddenly they have a cursive letter down the road, like a very italicized, weird letter. You'll notice it's like kind of slanted, like you can just tell it's written in a different font than the other ones. This is actually the name of the line. It's a different notation for it. So instead of writing, any 2 letters you pick, because I could pick any 2 letters, XM, it's the same line, right? It's the same thing. You could just write the cursive letter, the italicized letter that they put usually off to the side, and just put the word line in front of it. This is the same thing, but don't mix and match them. Don't write this. I always have somebody that will try this. Don't do that. This is just the name of it. It's not a point, it's not a dot on it, it's just the name of the line. But you have to write the word line in front of it if you're going to use that little weird symbol. Questions with what lines are. Now this is the thing that you're going to have to get used to when you see your textbook. When they ask, hey, name a line that passes through these 2 dots. When you name it, use probably the 2 dots they told you to, right? Use X or T or whatever letters they're telling you to use. Use those and then just draw the little mock picture above it, what it looks like. And again, the letters can be written in any order you want. But only 2 dots, 2 points, because that's in the definition. It's formed by 2 points. Questions, comments about lines, though? Okay, now we are going to look at 2 different types. I don't think, maybe not tomorrow, maybe tomorrow, but it'd be more like Friday or Monday. We're going to look at the other types of lines. There's 2 other types, and then that's where it gets really confusing, knowing which ones you should be using. But right now it's pretty easy. Lines, points, and then the last one is called a plane. Let's talk about that. All right. All right, a plane. Not an airplane, a geometrical plane. It is a limitless flat surface. It's a limitless flat surface. Now, here's the key thing about this limitless flat surface. It contains 3 non-collinear points. That is super specific. It's got a bunch of vocab words in there. A limitless flat surface that contains 3 non-collinear points. We're just adding more vocab words every time we get to a new definition. All right. Okay, let's talk about it. Limitless, what is it again? Forever, right? We talked about that earlier. So it goes forever, in all directions. Not like on a line, these went in 2 directions, right? Both directions, 2 directions. That one goes anywhere. So if you have a really good imagination, imagine my marker board. That's like a plane, it's a flat surface. Imagine that it extends through the floor, through the ceiling, through the wall, and through this way, and it just keeps going, if you have that imagination, right? That's a flat surface. Now, it contains 3 non-collinear points. This is a new definition. This is a new vocab word. I need to know what this means, because otherwise it doesn't make any sense to you. What does it mean to be non-collinear? Non-collinear. What's your opinion? What are we thinking? Please, what do you think?
3 points that don't match up with each other.
What do you mean by match up?
Like, see on there, X and Y, you can go straight through them, but I guess you could with any other line, but there's 3, if there's...
Okay, you're on it, right? These are all in a straight line. These dots you're seeing here, like you're saying, they're in a straight line. You can draw one line, passes through all of them. X, M, S, T, Y. That's called collinear. They're in a straight line with each other. Non-collinear means they're not. So if you pick any 3 dots you want, just make sure that it makes like a triangle between them. They're not in a straight line with each other. They're in like a triangle pattern. Any 2 dots will have a line, right? Any 2. But when you put all 3 in this weird triangle pattern, there's no way you can draw one line that will hit all of them unless it's curved, right? So let's call this A, B, and C. 3 dots not in a straight line. That's non-collinear. So again, not in a single line. Right? Collinear is in a straight line contained on the same line. Now, why do they have to be non-collinear though? Think about this. Why is there only one plane that can hit A, B, and C here? Think of a flat surface. Why do they have to be like that? Why can't I just put 3 dots like this? You agree that these 3 dots are on my flat surface, my marker board, right? You can see it. Like I physically even drew them on the marker board. You can see they're on one plane. These are in a straight line. That thing says it has to be not in a straight line. Here's why. Why they have to define a single plane. Sure, these 3 dots, one plane touches them. If I pick a plane, here's my flat surface, right? Imagine it's flat. I only hit 2. I tilt it this way, I only hit 2. Tilt it this way, I only hit 2. I'm always missing one of them. So the only flat surface I can hit A, B, and C at the same time, bless you, whoever sneezed, is my marker board. Over here, sure, the marker board touches M, S, T, X, and Y, but there's also other planes that could hit these 3, because I could tilt my plane, my flat surface, at an angle like this, and now I hit all of them again. And this isn't the same plane as the marker board. This plane's coming out at you, right? If I just tilt it a little bit, this is a different plane now. It's got a different pitch to it, a different tilt, a different slope. So that's a different plane completely. But it's still hitting all 3 of them. So to make one single plane, a unique surface, you have to be not in a straight line. That's the idea. That's a really hard concept to wrap your head around. They got to be non-collinear to make a very specific plane. Otherwise, there's too many options. There's an infinite number of options because you could just spin around 360 degrees all the way around this thing. Okay, now to name this object. So maybe the question in your homework says, hey, name a plane that touches A, B, and C. Name one plane. Well, this is how you write. Just like the line, just like the point, you write the word plane, the flat surface, and then you write the 3 letters you need to hit. Well, I need to hit A, B, and C. Has to be 3 dots or more for a plane. I always recommend 3 because that's in the definition. In a line, how many points do you write? 2, only 2 because that's a part of the definition. So that's how you do it. So it's pretty easy. Plane, line, you get the idea. If they use a weird italicized letter, you'll probably notice it. You can use that, but you have to write the word plane in front of it. So if they put, maybe this is plane R over here. It's big and italicized, you'll notice it. You can just write plane R. All right, it's not a dot. You can see there's no dot next to R. It's just the name of the plane. It is my marker board. Questions with the notational stuff. I know that's boring stuff, but I'm super particular. When you write your answers, you have to write them very specific. If you leave the word plane off, I count it wrong. Gone. You would not believe how many people miss points in this first assignment that you have to redo. Because you just forget the little things. You forget to write the word line. You use the wrong 2 letters. You don't put the little symbol above it, that type of thing. or you use a mixture of these plus the italicized letter, and I count it wrong because you're not doing it correctly. You got to get used to that concept. Okay, questions with the basic vocab: points, lines, and planes. Okay, at least you have it written down, hopefully somewhere in your notes. Now, these three objects, that's it. Those three objects make everything in geometry. Literally everything. Every shape is made from planes, lines, and points. The weird thing is when we start talking about, how do you form a point, how do you form a line, how do you get a plane, that's when it gets really weird. Those are called intersections. There's different interactions of geometrical objects. So let me talk about those different types of interactions. Now, we're not going to go through these formal definitions today, but I want you to at least have these vocab words in your in the back of your mind, so when we get to them maybe tomorrow or Friday, you at least know what I'm talking about so you're not lost. This is a terrible color. That blue does not come off the marker board very well. Okay, so anyway. So the types of interactions between objects. Okay, so geometrical figures, right? Lines or planes or whatever they are, whatever objects you have, there's different things that could happen. Number one, they could intersect. What is the basic idea of what is an intersection? Where they cross, right? Where they touch, they meet, they share a point. So things could cross, right? You could have two lines, they cross each other. Well, if you have two lines, right, here's a line, I have two dots on it, and they cross another line with two dots on it. That's an intersection, right? They shared a point. They shared one dot. Right there. We'll call it point P. That's the intersection. So if it said, hey, find the intersection of these two lines, well, that's point P. That's the intersection of two lines. Right? It's a point. You have to write the word point. You have to write the capital letter after it. Does that make sense for the first type of interaction? Super easy. Most of that makes sense. They cross. Cool. It could be anything. It could be two planes. Think about two planes crossing each other. Here's a good example. My marker board wall, this wall right here, and the ceiling. They crossed each other. Right? They intersected. In fact, they intersected right at that weird line up there. So when planes cross, they make lines. Think about that. To make a line, you have to have two planes crossing. The best image I have in my head is hold out your hand. Like hold your hand out flat in front of you. Imagine that's like a piece of bread. You have a piece of bread in your hand, and you had a butter knife in your other hand. A butter knife. But instead of like putting butter down on it, you actually slice the bread. Right? You cut through the bread. What happens to the bread?
Cool.
Say it again?
Cool.
Yeah, you have two of them, but what does it look like between them? You're right. You have two pieces of bread now, right? But what does it look like between the two pieces of bread? It's a line. You made a perfect line when you have that plane crossing another plane. The butter knife is your plane, right? You're seeing it. You can actually see it right in the corner, right? You have two walls meeting. They make a line right in the corner. My two marker boards here. These are distinct marker boards. When they crossed, they made a line. The little metal beam between them. Lines are made from two planes crossing. Now, that's a type of interaction. Number two, they can be parallel. They could be parallel to each other. What does parallel mean? Please.
Or they can be like side to side.
Yeah.
And like never touch.
That's a great way to put it. They don't touch. It's a lack of interaction. Maybe they're just spaced perfectly where they'll never meet. They have the same slope if you go back to Algebra 1 class, right? They'll never touch. There's a perfect gap between them at all moments. That's a topic we're going to talk about later. Are things truly actually parallel? That's a question that we need to talk about. But it's a lack of interaction between objects. You could have two planes being parallel. You could have two lines like railroad tracks, right? They could be parallel to each other. It's a lack of interaction. That's still an item. Next thing. Number three, they could coincide. They could coincide with each other. That is the ultimate form of interaction because they are the same object. Think of it this way. I'm going to draw a line here. Let's call this line AB. There's my line. You can see it right in front of you. I'm going to draw another line right on top of it. That's coinciding lines. It could be a different line, right? I could call that other line that just crossed right over top XY. They're the same line. They just were right on top of each other. They share every point. The best way I always think of this, imagine you had a notebook, right? This happens to me when I was in high school. I'm writing all my notes in my notebook, I flip the page over, I start writing on the back of my piece of paper, and when I turn to open up my notebook again, I have pencil lead all over the pages that I just wrote on. You can actually see a perfect transcript of all the words I wrote on one side of the paper on the other side of the paper, right? Copied through almost like carbon copies. Because the pages are now coinciding with each other. They're actually laying down graphite from one page to another page because they're right on top of each other. They're sharing it. You see it with checks. When you write a check, if you ever have to write a check, you guys are young enough, you probably will never have to. But if you ever have to write a check in a checkbook, you'll actually see all the things you wrote on the check below it. You'll see the words you wrote, your signature. That's the danger of writing in a checkbook. You have to rip it out of the checkbook before you write on it. Otherwise, if somebody stole your checkbook, they know your signature. They can see it on all the checks below it. One of those things you think about when you're getting older. Now, those are the different types of interactions. There's others. There's perpendicular and orthogonal. There's other types. But these are the most common ones that we just need to talk about because I know you're booked for, in fact, we'll talk about intersecting. We'll talk about parallel today. Those are little things you need to worry about. All right. Questions with any of the vocab words I've talked about today? Perfect. Okay. Here's what I need to do. Just for a quick second, if somebody at your table can open up the textbook, it could be an online version, it could be the physical book, so I know some of you brought your physical book. Somebody open it up really fast. You need to get to page, I don't know what is it, let's go to page 7 in your textbook. Somebody open it up really fast. In fact, I wonder if I can pull it up just up here so you guys don't have to do that. See if I can pull it up before you guys do. Oh, perfect. All right, here we go. All right, so here's the picture I want to show you. Here it is. This is probably the easiest way I can do it. I'll just put it up on my board. There. There's a picture in your book. Kind of looks like this. It's on page 7 or page 8, something like that. It looks like that. This is the thing that you need to kind of wrap your head around. What you're looking at here is a plane. That's that weird piece of cheese looking thing. And you have two lines that are intersecting with it. There's one that's coinciding, and then there's one that's poking through it. So J, do you see the line J? That's italicized letter. So if I have to write that line down, I write line, the word line, and then put J after it. That line is coinciding on top of the plane. It's right on top of it. What about the line K? Why did it suddenly go dashed? Why is there a dash line all of a sudden?
Just because it's one they kind of meet, so you can.
It is definitely meeting. I agree with that. It's meeting right at that one dot. But why did it go dashed all of a sudden? Why didn't it just stay solid? Because what's happening with line K, and this is the thing you need to wrap your head around, is the way that the book draws it. It's hitting the plane, that piece of cheese, right here at this dot, and then it's poking through it. It's poking through. That's how you can tell. It's actually going down through the bottom of the paper. This dash line is the part where you can't see the pencil. It's behind the plane. It's underneath it. So this point down here is the pencil tip down below the plane. So this dot's the only point that actually touched the plane. That one doesn't, and this one doesn't down here. It's below it. Does that make sense? Dash. That's something you just need to see. You need to physically be able to recognize that. So they say, hey, name a point that's on the plane. Okay? I can name that point. Point whatever that is, whatever letter it is. Now, it could be a situation like this. Maybe you have multiple planes crossing. Now you have lines, right? You have this line right here. You have this line N right here. So that's where the two planes are crossing. They're dashed because these are in the background. You can't see it, like this weird piece of cheese going up and down that plane. it went behind this plane right here, this plane Y. Like getting your head wrapped around that it's just like two pieces of bread and you have that butter knife going through it, that type of thing. There's space in between. There's a gap between the two planes. Okay, does that make sense, like the types of pictures you're gonna see today? Okay, the big thing about today's homework, it's asking you to name points, name lines, name planes. The thing I wanna see is, do you use the right notation? If it asks for a point, are you writing the word point and the letter? If it asks for a line, are you writing the 2 letters with little arrows above it? If you have to write a plane, are you writing the word plane and the 3 letters? Does that make sense? Homework is on the boards, page 8. We're going to talk about it more tomorrow. I'm actually going to pull up a couple of the problems from your homework tomorrow when you walk in here, and I'm going to give you a couple of freebies. So I'm going to go through a couple of those problems. So I'm not going to leave you hanging. I want to give you time to work on it tomorrow in class, but I also want to do a couple of the problems and have your guys' opinion on it. So that's the assignment. Now that's going to be due on Friday. So it's kind of a short turnaround. You only got a couple days, right? But we're going to work on it tomorrow in class together for the most part. Make sense?
Yeah.
Okay, that's it for today.